Now let's see an example for push-down automata where the language is given as a raised to n, b raised to m, and a raised to n. Now the condition is given like number of n and m, it should be greater than 0. Now let's see what will be the possible strings generated with this particular language. So let's assume n equals to 2 and m equals to 1. So the possible string is like a, one number of b, and two number of a's. If I assume n equals to 3 and m equals to 2, there will be 3 number of a's followed by 3 number of a's. In between we have 2m. If we consider this particular case where one number of n and two number of f, it will be like 1a, and in between I have two number of b's. So if you observe, in between, before b and after b, there should be equal number of a's. We don't have to deal with this in between b's. So how we can solve this particular example? At the starting a's, whatever starting a's we are reading, we will perform push operation on it. On reading b, I will skip it, or we can say like I will not perform any operation on the stack. Then at the ending is I will perform pop operation. So what will happen? Those many number of A's got pushed in the stack, only those many number of A's got popped from the stack, and hence you can track there are equal number of A's before and after this B. And we don't want to deal with this number of B because it can be any number of B's available in between this string. Now let's design finite automata for the same. Let's say Q0 is my initial state. Now, as n and m is greater than 0, so it is required there should be one occurrence of A and one occurrence of B. So let's start like I'm reading first A alphabet. Here I am assuming like in the stack we have Z0 at the bottom. So as this is first character, obviously at the top of the stack we have Z0, and what rule we decided? Like to push it in the stack. So whenever we are performing push operation, so how we can write it? Like capital A Z0. So I am assuming capital A as a stack alphabet. So this will be your next state. Now after first occurrence of A, we can have any number of A's later on. So it will be a closure. So we will have a self loop on Q1. Your input will be still A, but instead of Z0, now what you have done, you have pushed this A in the stack. So your top of the stack should be capital A, and you are performing push operation only. So it will be A. Okay, so it will go on for all those many number of A's. Now what next? When B come, we have to skip it. So now we have to change our state from Q1 to Q2 on reading B. Now while reading B character, what should be your top of the stack? At least one A should be there. So here your top of the stack should be capital A, and we are going to perform no operation on the stack. So this A will be as it is. After reading this first A, later on we can have any number of B. So here we will have a closure on B. Again, we'll assume as a top of the stack A, that A will remain unchanged. It means we are performing skip operation. Now, after reading B, again we have to change our state on A alphabet. Now, for the last B's, for the last number of A's, I will read A, and top of the stack should be capital A. And now we are performing pop operation. So it should be null. Now this will be your Q3 state. As there will be more number of A's, so we'll have a self loop over here, and we will have A on the top of the stack, capital A, and we are going to pop it. Okay. Now how you will reach to the end state or final state? So now how we'll reach to final state? So after this, now you have read all the string. It means you reach at the end of the string. It means null. Also, you reach at the end of the stack. That is nothing but Z0. And it will be as it is. And this will be your final state. So this is how we can derive push-down automata for the language A raised to n, B raised to m, and A raised to n, where n and m is greater than 0. So what we have done for initial A's, we have performed push operation on the stack. Then on B, from this to this, we have performed skip operation, and to this we have performed pop operation. So this logic is used to implement push down automata for the given language. Thank you.